everybody. I'd just like to say as we start, you haven't really given a talk at a tech conference until you've had a kernel panic setting up your displays. But yeah, anyway, we're from Pebble. We're here today to talk about the Pebble timeline. I'm Charlie McConnell.
And I'm Lance Vick, and we're a retired magician, retired actor, and we've been playing with Linux stuff for a long time, and now we do that professionally.
We are the resident Linux weirdos on the Pebble DevOps team.
Yep.
So, Pebble. First of all, by a show of hands, how many of you are already familiar with Pebble? Sweet. How many of you actually have a Pebble? Also sweet. All right, so for anyone not already familiar, what is Pebble? We make watches. The core mission of Pebble is to just make a damn good watch. I'm directly quoting the CEO when I say that. So, since it's 2015, these watches are pretty smart. I'm told some people have gone as far as to call them smartwatches. All right, so the original Pebble in 2012 was it started out as a Kickstarter project. It got a whole lot more interest than anyone actually expected, and at the time, it was a record-breaking, more than $10 million Kickstarter. This is a picture of the Kickstarter from the first Pebble. As you can see, it's a very simple watch. It's black and white screen, all plastic, just a really simple device, but a ton of interest. $10.2 million in Kickstarter backing. For a long time, we were the record holders. Then, I think it was 2013, somebody made a really cool-looking cooler. And this beat the original Pebble. Now, I don't really know much about this cooler, but it looks kind of awesome. Go that guy. I hope lots of people are having fun with their margaritas and their coolers. But, fast forward a couple of years, and then this year, a few months ago, Pebble announced their new watch, the Pebble Time, on Kickstarter. This is a revamped design. We've got a color display. We've also added a microphone for voice capabilities. And this, we did a little bit better this time. I hear we gave Kickstarter a couple of bad days. Sorry about that. But yeah, so why would I want a Pebble? For starters, the thing that I like about it best, actually, being kind of a curmudgeon about technology, is that it is always accurate. The time is synced via its connection to your mobile device, so it's literally the most accurate watch I've ever owned. It's also got an always-on screen, which is what they would call an e-paper display. The idea with this is that it reflects light instead of emitting light, so it's big power savings, and it's oftentimes easier to see in sunlight. Because of this and other things, you'll get up to a week of battery life. Now, this is dependent on how many active, button-pressing games you're playing on your watch, obviously, but you'll get up to a week of battery life. And there are tons of cool apps, cool watch faces, integrations with companies, all sorts of stuff like this. So, what it isn't is, the Pebble is a relatively simple device. It's not a heart or health monitor. It is not a payment system. It is not a smartphone on your wrist. It is not a new pile of virtual distractions. Or, in other words, an overpriced trophy watch was not on our to-do list. So yeah, along with the Pebble Time, we've come out with a new idea for an operating system for the watch. This is the Pebble Timeline. The whole idea, when you think about an operating system, what you want is to have something where the information that you really want, the information that you're really after, is very readily accessible for you. And in the case of a watch, what you care about is time. So what this gives you is the basic, the most basic service interface for this operating system is just a timeline. You can hit one button to get to your recent past and another button to get to your recent future, upcoming events. So yeah, an interface for upcoming and past life events. It's designed to be really simple and to save you time, as opposed to being another thing that you're taking out of your pocket to press buttons with and stuff like that. Each event is called a pin. It can be easily created via our APIs. All of these things are just JSON objects. And for starters, without you having to do anything, your phone's calendar app is automatically synced with your timeline. So, what can I use it for? We're sitting here at a conference. There's talks going on all day, left, right, and sideways. Let's put the talk schedule on our watches. Lance?
Yeah, so let's try to do that. So to get started with the Timeline API, you have a couple things. You got a script, which is actually using the Pebble API to post pins. This is just a Node.js module you can grab off NPM. And a small watch app to handle the syncing of those pins. That's really it. So let's take a look at an example. Here is the Node.js library, Pebble API node, and you can create pins, send a pin to a user. Pretty straightforward. So let's go look at an example. We've got this JSConf 2015 schedule. There's no README because I did this at like 3 a.m. last night or something, but we got it here. So you've got to populate.js. This is the bit that actually matters, and it is very quick to put together in a hurry. You've got all sorts of stuff here at the top, which I'll show you. This is to get the schedule. This just parses the JSConf schedule web page and pulls out all of the data and whatnot. Kind of rage wrote some regex here, but it does the job.
Lance has that habit sometimes.
It's true. But so if you need to make a quick JSConf app, you can come steal this function, and it does the right thing, at least as long as the page format doesn't change around. But in any event, so we skip down to the part that it's actually really relevant here to get schedule, magic you don't have to worry about. All right, we've got a schedule. We come down here for each, and we just have pins. You create a pin, you have a topic, you have a generic pin layout, it's a notification, it's got a title. That's all you need. Then you send this shared pin to the JSConf 2015 schedule topic, and you can log it if you want. That's it. That's all it takes to make a basic app. The nice thing about this is that there's no server involved here. You just run this once, or run it periodically if you want to update. So that's your data source, updating the pins. Those pins are then posted to our server, and the watches then pull those pins from our servers and keep it in sync for you. So let's jump back to... There's actually what that looks like. Got a couple things in the timeline there to show what the next things are to do. That's what I looked at to realize, oh, hey, we have a talk that we're supposed to be at. So we did make it here.
Yeah, thanks, Pebble.
Yeah, so very basic. We provide an API. We have the Node.js library. You make content, and then you make apps that, the watch gets notified when that content is changed. So pretty straightforward. Here you can actually create, update, delete pins. Pins are attached to either topics or users. So you can either attach a pin directly to a user, and that goes to only their timeline, or to a topic, which goes to many users. Apps subscribe to the topics. The watch passively updates that. And you can notify the user if it's something that matters right now. You can give them a notification. Else it's something they can just passively check.
All right, so let's go over some of the tools we've used here. It's all pretty standard stuff. We use MongoDB as our primary data store. It's all built in Node.js and CoreOS as far as our application runtime is concerned. We've got Redis in place as a cache and to handle rate limiting for the timeline APIs. And the actual notifications are handled by a pool of workers which are pulling messages off of Amazon SQS. No real rocket science here, just good solid stuff. So let's talk about our web infrastructure. Let's talk about how we've actually built and deployed this whole thing. So the philosophy that we have is best summed up as version-controlled immutable deployment. Now, what this means is the idea that if you're making a change to your infrastructure, that is actually even more something that you should be tracking in version control compared to your code. The idea is that if you're making a change, it's getting tracked. And immutable deployment is the idea that you are deploying an artifact that is the result of something. It is the output of a program. And if you are then going in there and making manual changes to it afterwards, you're doing it wrong, and you should actually be fixing the program so that you always have correct state as the output of something. This is the whole idea of this. So version-controlled deployment, let's start there. You're going to deploy, you're going to make a git commit. If you're going to alter the infrastructure, alter the size of a cluster or the size of an auto-scaling group, you're going to make a git commit into the files that track that information. If you have configuration data, environment variables, configuration files, however you're tracking that, and you're going to make a change to it, it's really important to keep it in version control. Because that way, when someone fat fingers a value and things are broken all of a sudden, you can be like, oh, I see what happened now. That thing was mistakenly edited. Okay. And then it's extremely wise to back this up somewhere. We personally use an encrypted S3 storage for this. And the base of our deployment system is actually available on GitHub at Pebble/git deploy. So to achieve the immutable deployment side of this, we use containers. The advantages of containers is that you get a clean system slate on every service run. It's like a subdivision of an operating system, so you don't have things cluttering each other's spaces. They can't see anything else running on the system. You use namespaces to make sure that everything, like the first app running in a container usually thinks it's PID 1, and it can't see anything else. If you're doing it right, it can't see anything else on the system. can also, on Linux, these are built out of namespaces and control groups, which are kernel level features for keeping things separate from each other. One of the big advantages to this is if you've ever worked with Python and used virtualenv, you will never have to do that again. So yeah, specifically, we are using Docker for this. As of today, it's the most mature containerization solution. It allows you to very, very easily create containers from a blueprint, namely a Docker file. And the Docker file is just, think package JSON for servers. It's a very simple concept, relatively straightforward configuration file. Now, there's a lot of really good things about Docker. There's a really, really big, really active ecosystem. If you are, if you want to experiment with something you haven't deployed before, the odds that someone else has a ready-made Docker container for it are really high. Now, you may not want to deploy that straight to production, but if you just need a quick setup for something, it's really great for that. It's also really easy to get started building your own containers. Docker is, the Docker file syntax, mostly not rocket science, not too many surprises. It's an easy thing to work with. And Docker also gives you really easy interfaces to things like, by default, Docker containers use this virtual networking bridge so that they all have their own virtual IP addresses and stuff like that. Setting that up manually, not so much fun. Dealing with C group resource limits manually, not really all that much fun. With Docker, it's just command line options and everything's pretty easy. Now, as you might imagine, it's not without its hardships and faults. The Docker file syntax can be kind of quirky and surprising. If you're copying a directory, you can't forget the trailing slash, or you'll have an unreadable file containing all of the contents of your directory. It's also really, really easy to make really, really big Docker images. If you're starting your files with from Ubuntu, if anyone who is part of your base image is starting with from Ubuntu, you're starting out with 1/4 of a gig on disk. And then it's real easy for apps to get way bigger than that. We have a couple of things that are over a gig, and it's really kind of surprising. Logging also, unless you are handling things yourself, out of the box, Docker only knows how to pull standard I/O out of these processes, and it tends to hang it around in memory. All of a sudden, if you've had a busy process, you'll notice that the host is slow because the Docker daemon is using like 40% of your RAM and not really behaving very well. Docker also, it doesn't tend to clean up after itself when you pull changes, so if you don't pay attention to it, you'll have your disks filling up from lots of dangling image layers. In addition, probably the most important thing to remember about Docker is that if you are root inside of a container, you are root on the host. They do not have a separate UID space for these containers. So it's super, super important that you drop privileges, always. There's lots of advice in the community that you don't need to worry about this. You're in a container. It doesn't work like that. It's not really true. It's kind of dangerous in this sense. You absolutely have to drop privileges. And if you're in a position where the only thing you only need one specific thing that you might otherwise use sudo for, like binding to port 80, they have these things called Linux capabilities. The one in particular, capnet bind, will let you bind to port 80. There are lots of these. Further investigation here is left as an exercise to the viewer. So yeah, after a pair of slides full of hardship there, are there alternatives to Docker? Well, there's a couple. The first one, the one that interests me the most, is systemd nspawn. Now, systemd made this over the course of the last few years. They made it pretty quietly because it was not really intended to be like a publicly advertised product. They built it as their test harness. Because if you're an init system, you always need to be PID1, make a container. All of a sudden, they started to realize this had actually become pretty solid, and as of the last version, they quietly added the ability to pull and run Docker containers. So that's brand new, and it only works on BTRFS, but I'm really interested in watching that. There's also a product being made by CoreOS called Rocket. They are trying to gather lots of people together to create an application container spec, and I'm very excited about the direction this is going, but they're not as mature as Docker. These are in-progress things. Rocket, I think, is version 0.5 or something like that, and you watch them in the long run, is my personal opinion. All right, so if you're going to deploy with Docker, it's easy and convenient because the only thing you really need on the server is the Docker daemon. The containers themselves will contain all of the kinds of dependencies you might need, so all you need is something to run your containers. There's several modern distros that already ship with Docker. Red Hat in particular will ship with Docker. However, not all of them actually ship with a recent Docker, and so you'll need to pay attention to how old it is, if there's any outstanding security issues, things like that. I would say the bottom line, though, with all of this, you should choose a distribution that you're already comfortable with, because it's just not going to matter all that much in the long run. If you spent your whole career using apt-get on Ubuntu and Debian, you're going to have a bad time with Red Hat because it's really different in ways that aren't going to make sense to you. So, yeah. For us, the distro that we've chosen to use is CoreOS. It is a minimalistic distro. It is designed for containers. It ships with the Docker daemon. It is designed as a clustered container deployment target. CoreOS is also a curated rolling release. We get the latest versions of everything after they've hit some testing. And for us, that means we're on the 403 kernel, I think. We're on Docker 1.62. It's very recent stuff. And so CoreOS is based on ChromeOS, which is itself based on Gentoo. So what we're basically dealing with here is a source distribution that was curated and locked down by Google, and then that was taken and curated and locked down by the CoreOS guys, and now you have a server operating system. There's a lot of things that are really good about this. As I said, it is ready-made for deploying with Docker. The distance from 0 to 60 doing this with CoreOS it's just really easy. You don't have to install anything. It's also a systemd distribution. I'm a big fan of systemd. Systemd adds consistency where none existed before, and the dependency management that you are able to have between services and mount points and parts of the operating system is not something that you get otherwise, unless you feel like writing a couple thousand lines of bash yourself, which a lot of people who don't like it appear to do. CoreOS also, it ships with etcd. Etcd, if any of you aren't familiar, it is a strongly consistent key value store. It's a lot like Redis, except its emphasis is on consistency as opposed to high availability and performance. It's designed for keeping things safe as opposed to being a fast cache. CoreOS also comes with a neat tool called Fleet. It is designed as a distributed wrapper around the systemd instances that are running on all of the nodes in your cluster. There's a lot of really cool things about Fleet. As nodes come and go from the cluster, Fleet will just say, oh, okay, I'm this type of node. That means I need these services. Let me pull those services from etcd. Let me start those things, pull the Docker containers from where they come from, and then when your cluster auto-scaled in the middle of the night, everything started like it was supposed to because you've got a distributed init system. Now, there's also, CoreOS also has a really cool automated rolling updates feature. They actually have this thing where you've got two separate root partitions, and they'll update one while the other one's running. It's good stuff, but the thing about this is that if you leave it with the default configuration, it will reboot to apply those updates, which is cool and really fast because of that thing with the two root partitions, but I promise you, you don't want this happening in the middle of the night. You might think you do. You don't want this happening in the middle of the night. Luckily, it's easy to turn off, and the updates still download, and you can do it yourself with one command. In addition to this, the current default version of etcd, etcd 0.4, is problematic. They've got a new version. It ships with CoreOS, but the binary is named etcd2 because they don't want to be pulling the rug out from under people. Etcd 0.4 is problematic and is definitely something that you should be careful about using. New deployments should not go anywhere near it. Another issue is that Fleet sounds like it's really awesome, but it's super, super simple and not really not a complete deployment system. And additionally, a number of the quick, easy fixes to these problems involve subscription services from CoreOS, which is what it is. Anyway, back to Pebble. Our deployment pipeline starts out, we have a private Docker registry. We use that to build images based on Git pushes and to host the images for us to pull to our infrastructure. We've got in our staging and development environments, we've got a webhook server. The Docker registry will give us a webhook for this when the builds are complete, and then in staging, we automatically restart the services. In production, we're a little more careful than that, and we run everything off of a custom Git repo, as we were talking about before with this, the Pebble Git deploy. And we base everything on just post-receive hooks and all of that. So yeah. At Pebble, we are firm believers in using the right tool for the job. Because most of this stuff is Git hooks, we're about 90% bash where the deploy pipeline is concerned. We've also used little bits of Go here and there because with Go you can make a really tiny binary. Fairly straightforward language, you can make really, really tiny binaries, like a 5 megabyte Docker container and stuff like that. Gets pretty cool. For us, these Docker images are the immutable deployment artifacts that I talked about. Every server, every state of every service should be the output of a program. If it's misconfigured, fix the program. Finally, a quote from an old friend of mine: redundancy, resiliency, scale. This is how you survive unexpected things. You always make sure you have backups, you make sure that things can be deployed automatically, and you make sure that if servers suddenly start exploding, there's something that you can do about it without a ton of fretting and head scratching. All right.
So yeah, we're here to solve real-world problems with watches, and a lot of these real-world problems, what's there food around me? I'm hungry, and I want to be able to see that quickly at a glance. Where's my train? Rather than pulling my phone out and checking constantly, is it here yet? Is it going to be here? What's going on? Or where's my driver or whatever? When's my next talk? As we mentioned with the JSConf demo, you could totally add those events to your timeline and actually know when your next talk is. Is the restroom free yet? All right, I need an honest show of hands here. How many have really need to use the restroom at your office and you found out that everything's full? Anybody? A few honest people? Okay, all right. Yeah, it's actually really inconvenient. It's a time sink. In fact, I would say that, yeah, it's very inconvenient. It's probably our biggest problem as a company. So if you think about it, right? So fast growth, 180 employees, catered lunches, right? 4 toilets. So we haven't got we have to rethink the office situation, obviously, but yeah. So at the moment, it's a problem. So we have to solve this problem. So a solution for that: a lock state sensor, Arduino, a Node.js server. We're a JavaScript conference, right? And a Pebble watch app. So we can take a look at what that looks like here. So I've got the toilet time repo here. So, and actually, let's just go through and see. There's actually a README, shows you some of the things that are going on here you can play around with. Let's actually dive into the code. So there's 3 parts to this. We've got a lock client. This is actually just some Arduino code. This just shows you that there's a lock pin, there's an LED pin, there is Ethernet. In this case, it's listening on the lock pin state, whether it changes to on or off, and it sends a manual post to a server. And we should actually give you a look at what that looks like there. Yeah, something like that. So I don't know about you guys. I'm pretty sure this is production ready. We're getting there.
Ship it.
Yeah, exactly. But we got the lock sensor there. It goes down to Arduino, updates the server. We're good to go. So we go through the posting of JSON. Let's go look at the JavaScript. So for the JavaScript, we've got CoreOS router, which is actually an in-house project to make a nice validated router for Koa. Here we've got route v1 update. It's a post route. Go in a little more, catch the body if there's not anything, and we check the state coming in. And the state coming in is either going to be locked or unlocked. We say if it's either occupied or vacant based on a 0 or 1 that we're receiving. And here's the bit that is, again, very simple. We're creating a pin, and this is just a generic pin. Bathroom is either vacant or occupied, and we post it to the timeline. That's really it. That's all it takes. And these 3 parts work together. And you could actually refactor this to be something a little different. Perhaps you want to know on your timeline what the temperature is of your very tightly controlled aquarium at home, or anything to get data from a source, get it to a server, and then project it to as many watches as people care about that piece of information. So let's just jump back here and show you what that looks like. Here I've got bathroom vacant, and it's actually working right now, and I can actually find out the status of the Palo Alto bathroom and whether or not it's free, because that's really relevant at the moment. But
I have never been more disappointed to be a remote employee.
Yes. So yeah, that's a fun demo, and hopefully gets you thinking about the things that you can build with Pebble, and go grab the Node library and try it out.
Thanks. Thanks. In closing, Pebble is hiring like crazy. So if you do any of these things, you might have to squint at right now. By all means, come talk to us. Pebble.com jobs.